So we've looked at how to find the argument and the modulus, and if we've got a complex number, then we can find the argument and the modulus, and we can use that to write it in what's called polar form. So polar form is that form that I've talked about that goes the complex number equals r cis theta. What that actually means is r cosine theta plus I sine theta. So this bit is our normal rectangular x part, and this is our plus I, and this is our y part. You can see that off the graph, in that if we look at the graph, right, we're using cosine, which is this one over this one, so that's that distance there, and that's our x distance. Sine is that distance over that one, so it's our y distance. That gives us our complex number. So we can easily change from rectangular to polar. So how do we change from polar to rectangular? So if we've got a polar coordinate of 2 cis, and they'll often be written in radians, so they'll always be radians, but with pi's in them. So we've got this. All we actually have to do is expand it to cos pi by 3 plus I sine, whoops, forgot the 2, because the 2 is in both parts. All right, so there should be an r there as well. All right, sine pi by 3. All right, so remembering that that 2 is in both parts. So we've got, what is cosine pi by 3? It's 2 times, it's actually a half, using special triangles. All right, so a special triangle looks like this. This is pi by 3. This is pi by 6. Right angle triangle. Those two all add up to 180. And what we have is cosine 1, 2, square root 3. All right, is how it works. So that one equals cosine 1 over 2, and this one equals 2 times sine, which is pi by 3 over 2. So we end up with I. So we end up with 1 plus root 3i as our answer. Now, there's obviously an easier way to do this, and this is using your calculator. So if you're using your calculator, you go to options, and you go across, so use the F6 crank to go to the next page, F5, which is angles, all right, and then F6 to the next page, and then you've got two things. One says polar, and one says rectangular or real or something, RE, I think, all right, and what it's asking you there is to find that. So for doing this one, we'd be using, I want the real coordinates, and then we put in r and theta. In this one, we put in x and y. So if we put r and theta in, it will tell us that 1 is the real part, and root 3, but they'll give it to you in a decimal, is the imaginary part. All right, so what do we need else to do with these? I'm going to get rid of that little picture, because I'm right here. So, multiplying and dividing. Let's start with multiplying. Right, we're finding the product of two, this time, polar complex numbers. All right, so if we've got A is equal to K cis theta, and B is equal to M cis, oh, that's awful. I'm going to use delta, different angle. So when we're multiplying them, A times B, what we do is we multiply the moduluses and add the arguments. So it becomes K plus M cis theta plus delta. All right? If we're dividing, so A divided by B, What do you think happens to this part? Oh, that's times. I said times. What do you think happens here? Yep, it's the first one divided by the second one. So therefore it will be k divided by m. And here, yep, you're right. We minus. So theta minus delta. Pretty easy and straightforward. And all you have to do is carry it out. So let's have an example. If W equals 2 cis pi by 3 and Z equals 3 cis pi by 6, good numbers, then WZ will equal, so timesing 6, cis goes in there, adding these two together, pi by 3 plus pi by 6 is what? So that's 2/6 plus a 6 makes a half. Pi by 2. All right? And if we're dividing, we've got this time 2 divided by 3, W over Z. So 2 over 3, cis, and subtracting this time pi by 3 minus pi by 6. 2 pi by 6 minus 1 pi by 6 equals 1 pi by 6. And that's how you write it. Okay?